The next school I'm going through will be Chapman Middle School. Now, this school consists of the new added equipments, and there's the demo that happened, and you have an old equipment still there. There will be a time, maybe next month, where the old equipment will be merged to the new system. Their location is booked on the graphics, so once we finish the conversion, you will see them along with the others. Of course, they will be a little bit different because the old equipment have a different feature, different stuff, different readings. So it won't be consistent exactly same as the one that we have right now. Pretty much the startup screen is not a big difference from the Chapman primary. Everything is the same. Same feature, no school, snow day, summer day, the force, the alarms. The freezer and the cooler, those are on the old system. So once we have the conversion done, you'll see them here on that spot, okay? This is reading for the outside temperature, same thing, night heating, cooling set points, and shelter in place. So everything pretty much here is the same as Chapman primary when it comes to the start screen. We can probably move forward with it. Okay. I want to start, for example, from the floor plan, because the RTU summary also the same as the one we had before. You will have 2 pages, so this RTU summary is covering the new equipments that you have, and then we will add another page will be for the old equipment after the conversion, okay? Almost, well, I would say exactly the same, right? There's no difference between the primary and here. So I'll move just to the floor plans to explain something here. You have 3 sections of the floor plan. You have the first floor and second floor, and the first floor B section, just an extension for the first floor. You can select whatever you want to navigate through your equipment, and example here, the one we have here, is for the first floor plan. You can see here, for example, those are booked values. They're not being filled yet because, again, the gym is an old system. And this is the new. Everything is color-coded to show you what is being covered by the equipment itself. You have some old equipment was covering multi-zones, right? You have multi-rooms covered by the same equipment, so it's being color-coded to show you which equipment serving which, okay? The major difference between this equipment and the Chapman primary is the heating elements. The primary school have a gas heat. This one have 2-stage electric heats. That's the only and one difference between the equipments of primary and Chapman Middle. Everything else is exactly set up the same. Control-wise, from A to Z.
Are those heat pumps? Yeah. Electric heat.
Electric heat.
It's our electric heat.
Those are electric heats.
So they're not heat pumps?
No. You have a DX cooling, hot gas reheat, and you have electric heat. 2 elements, electric heat. In certain areas, Chapman Middle, you might gonna have a complaint about the room temperature, saying we feel hot in the room. Well, you're looking at it, it looks very good. Space temp look pretty adequate, and everything is good. The only thing you want to maybe pay attention for is the discharge temperature. Sometimes the 110 degree will be overwhelming in some areas. So whenever it go to the heat mode, they can feel the exchange of the air with heat. It's pretty overwhelming for the occupant. Depending on how the registers of the air has been installed, has been managed in the space. So you probably just want to change your discharge high limit set point, because this is a set point. You can take that down to whatever you want. 95, maybe, it's a pretty good one, in case you have a problem with some certain zones during the heating mode, okay? Additionally, we have here roof plan beside the floor plan. And the roof plan is showing you the old and the new equipment all together on the same surface. You have the exhaust fan also that running here, and every one of those is also clickable. Like you can see the status of the fan from here, if it's running or not, the label of the RTU itself, what RTU you're looking at, and once you click, you in. It'll take you to that unit. Let's talk about the difference in those equipment that we have, like the major change. You have a makeup air unit and you have ERVs. Two ERVs, named ERV 4 and 7, and you have one makeup air unit. Here in this area is your makeup air unit, is beside the gym area. So this green head equipment, basically a 100% outside air. You're not going to see that damper on a 50% or 60% or so ever. It's going to be either 0 or 100. It has the ability to cool, heat the discharge temperature, not the space for sure. Because what you're trying to get from a makeup air unit is a neutral or room neutral temperature out of discharge temperature. So like right now we have a 69-degree discharge set point and our discharge temperature is 69, so like 70 by 69, almost the same. And that you can see the primary heat is on, which is electric heat. It's an SCR heat. Those makeup air units are providing for I think the boys' locker rooms and the girls' locker rooms. There's two space temps. They're not adjustable locally. You can only adjust them from the BAS, okay? Every room temperature will be controlled by the duct heater that's specified for each zone. You have one going to the boys' room, the boys' locker room. The other one goes to the girls' locker room. Whenever there's a call for example, you see here the girls' locker room is 69 degrees. So this is the one is serving the girls' locker room right now. The duct heater was actually controlling the temperature after that. Prior to that, you have always a room neutral.
That's kind of like a VAV right there. It's kind of like the VAVs.
Yeah, kind of like the same concept, except there's no damper to modulate the CFM. Of course, in the summertime, the discharge set point will be different.
What controls that to keep going if it's just the thermostat setting?
Yep. The discharge set points in the summertime will be pretty much 55, maybe 58 all the time, because you're not going to pour like 70-degree discharge in the summertime. You'll be having a pretty warm zone into that, and also it will help humidifying the air that's going into it, because you have 100% outside air all the time. Now,
Are there exhaust fans that work in conjunction with that?
yep. So if we go back to the to the roof, you see those two exhaust fans. They're supposed to interlock with the makeup air unit. When they are spinning, running, then the makeup air unit is not going to run. If both of them went down, makeup air unit will stop, will shut down, because it's pushing air and there's no exhaust for that air. There's no, how it goes. So we want to make sure those exhaust fans always running, because if not, you're not going to have any temperature control in that space. Any question about this equipment?
So, the unit for the locker rooms, that unit won't run unless the exhaust fans are running?
Yeah. By sequence of operation is interlocked with the exhaust fans.
Okay, well,
Something else that exhaust fan, you think?
well, those two new exhaust fans, they have instead of the old style, they just have light switch. That way you can change the motor, change the belt, whatever.
That's right.
Those two exhaust fans, I know this because we went through and checked them a couple months ago, they have breakers on them. And whenever we went through and checked them, they were both tripped.
Okay.
So that would stop that unit from running.
That's right.
Okay.
Yep.
I remember it, you know, was the one
Yeah.
that found that.
Both exhaust fans have to run before that run, or just one?
I mean, it's right now programmed as one, either or. Both, of course, is the best case scenario. But I mean, if you have one exhaust fan running, you have to serve it, right? Yes. Anything else we have here? So this equipment have a different setup. It has a hybrid control. What I mean by hybrid control, it has a factory controller for heating and refrigerant control, and it has our control, which is a custom control, to command that factory controller what mode we are trying to get. What is the goal? What are we trying to achieve? Are we trying to achieve a heating set point, a cooling set point? Are we trying to open a damper or close it? Are we trying to run the fan or so on? So what sometimes you can probably run that manually, right, from the factory controller?
Can't run it manually.
Yes, makeup.
Yeah, that's an option. Yeah. And you can see here it says global alarm is active. That global alarm, you have to go locally on the factory controller, and it will should display what kind of alarm you have there. Okay, that's how the global alarm is just an indicator. There's some sort of alarm, but for you don't know what it is specifically.
I mean, it could be a dirty filter, it could be anything, any kind of alarm, big alarm, small alarm, it's gonna trip the global alarm.
Yeah. Right now, you'll have a alarm, for example, for a supply fan from here. You will know if it has a alarm because right now you have a status. If you don't have a status, it will trigger an alarm for you. Filter, same thing. But some other details that not be shown here, it will be always on the local factory controller. Okay. So let's back to the roof plan. Let's look at one of the ERVs. This ERV, which is basically an energy recovery unit, can you, Jeff, speak about the recovery part of that equipment and how it differs? Not the heat wheel, the one that you started up, I think, in Chapmanville.
I'll wait till we get
Yeah.
on the site and we'll go through it.
Yeah, okay.
Yeah, that'll be the
All right.
easiest.
So it's pretty straightforward on that side. Just a heat energy recovery compartment in the equipment, and then you have exhaust fan, supply fan. You have outside damper, exhaust damper, return dampers. So there's not a lot of things going on with that except the recovery part. And there's electric duct heater that controlling the space temperature. Now there's two space temperature controlled by one duct heater, not two duct heaters. That's why you have an average zone temperature instead of just one for each.
What's that feeding the bathrooms?
I think so.
Which one is
The ERV
it? Yes.
Yeah. Yeah. Now, those numbers has been balanced. The 85% fan speed set point and exhaust fan set point is being balanced and determined by the balancer. But it's a set point, so you can take it down or set it up. Same thing for the makeup air units. You have a fan set point where you can just change the speed to whatever value you want. So at this moment, I don't think it needs to be changed, but we're not sure about the future.
What would be a reason to change it?
Huh?
What would be a reason to change it?
Positive or negative pressure anyway.
Be like
That's the
any,
only reason, really. That's the only thing that could possibly make you want to change it.
could be. That's one of the reasons. I mean, somebody just like to have it on 100. Who knows? So it's not a forcible value. It's like you don't need to force it. This is just a set point change, just like the others. All right. You have any question about this ERV? I think we have another ERV, 7. Just this one, the difference, it has 2 electric duct heater. So it doesn't have like one duct heater and averaging the zone. You have 2 duct heaters, so each one of them is controlling its own space. Okay? So it's not running right now because pretty much satisfied. Zone set point versus the temperature.
In unoccupied mode, these do not run at all, right? They're totally off,
Yeah.
just when students are present.
What's the main function of them?
Ventilation,
Ventilation, energy recovery, yeah. They're not really cooling or heating, it's just, probably you have some miscellaneous areas like restroom or whatever that where you need, instead of just an exhaust fan, you have an energy recovery unit put there.
and with an exhaust fan, you're losing any heat or air conditioned air. In the RV, you're
So-
using that to
so that-
preheat or pre-cool your
It just maintains.
air you're bringing in.
Plus you have electric duct heaters on those, so your exhaust that will have some heat gain coming from the electric duct heater, you don't want to lose that all the way, so that where the energy recovery comes to give you more of a close to room temperature discharge temperature. So exhaust fan 1 and 2, I don't know, those are the old ones. We have a CTs on them right now. Shows red propel. That means they are being commanded to run, but they don't respond. Okay, it's either a breaker, could be a just light switch, could be anything. But that's your alarm that that exhaust fan is commanded to run. It doesn't respond. You will see a red color on the propel. Okay. And those exhaust fan also run, I think, by occupancy, just schedule wise.
Logan Middle, about 3 exhaust fans that are working, but it shows not working.
We don't have, on Logan Middle, I don't think we have an indicator for all the exhaust fans. If they are.
I think so, they were working.
Mm-hmm.
Because there was like 3 of them, what?
Okay. Well, that's-
I think it was ERV, like 2A, 3A, I think 4.
You talking about the RV, the roof vents? Because there's exhaust fans and there's a roof vent.
No, I don't. There's just got to be.
ERVs is what he's showing.
I can show you, whenever you bring in Logan Middle up, I can show you.
Well, the roof, those are, I think they're mainly serving the fan coil units, I believe. There it is. Those are what for. But the overall exhaust fans that you have in Logan Middle, we don't have a status indicator of those exhaust fans, okay? Only the RVs. Only the RV style vent, the roof vent is the only one that we have this as. And the reason for that, because we're using those to work with the actual FC units inside the zone, okay? But by the way, you have a bunch of exhaust fans there that we are control only the emergency shutdown for them. And some of them, they wasn't already working. Remember that? Yep. So, yeah, those only RVs. So you're saying those RVs, they were working and actually doesn't show on the graphic they are not?
I think the one of them was all the way to the far left on the screen. Is that an exhaust fan or you got it pulled up there?
Yeah, okay. Let me show it to you here. Okay. Before I move from here, do you have more question about
Is
those?
this a global schedule or individual?
Okay, schedules on those, also local for each one of those. So it will be,
So each room will be individual,
yeah, each one will be individual. Even the old one will be the same. And you can see,
just like Chapmanville primary.
that's right, exactly the same. Back to the dashboard before I move on the floor, on the roof plan of those. The dashboard here, you have almost the same feature. Alarm, force, snow day. Now, summer mode. There was not a summer mode spec'd in Logan Middle, but if you want that to be added, I can add it to you.
Yeah, I need to be able to turn all that hot air on. I mean,
On the summertime?
yeah,
Okay. So if that's something you want,
yes,
yeah, okay. Well, we'll make it happen, no problem.
yeah, because that building's known for alarm mold.
What I want to draw attention to here, the average zone temperature. I put a little description here. The average temperature is an average of 20 plus zones at the time. So each one of them is represent different 20 zones in your school, and that's the average temperature for those 20 zones, okay? So you can log in and have a quick look if your school look really bad or really good out of those, okay? They've been mixed randomly. There's some from the second floor with the first floor, could be the corridors, so it's overall. So instead of coming with one temperature, I'd rather to split that to 4 different locations, and we'll give you just a quick indicator. That's pretty much what it is. I will jump to the roof plan on, so we can discuss those. Yeah, so those, I'm talking about this one
Yep.
and this one. This one is running, this one is running, this is the only one.
The one right there in the middle of spring,
This one?
Oh,
Oh,
yeah,
this,
there.
uh-huh,
Is that what's supposed to
run.
It's not spinning.
No spinning, no, no, no spin. So that means it doesn't have a status.
Should it have a status?
It should have a
Is that the one
status.
you said that was running?
Yeah, you got that.
That one
On
was
top to the
running,
left.
the one up here on the top left, that was running, and there was another one,
Oh, the others look like they're running.
This one here?
it was one of the ones over by the gym. There was 3 of them, but it looks like they're all running today. Maybe the motor's getting hot, kicking out.
I mean, that's, as far as
I'll be there
those,
tomorrow, I'll check it.
Yeah, but then there was 3 of them. Cause I made them go around and check them the other day.
so 3 of them was not running, you say? Or 3 of them was not running
No,
here?
they was running.
Uh-huh,
Physically.
physically, but here they wasn't showing.
Correct.
Okay. Okay, I mean, we can, tomorrow we'll be there and we go through them on the roof and see which one's running, which one's not. If there's, as he said, if there's like a CT adjustment need to be done, we can adjust that. Because sometimes they probably will start on a certain amp, and if the speed adjusted later on, then the amp will be also changed, so we'll lose the status on those. So. The roof plan also showing you all the equipments that you have on the roof, including the chiller. Chiller, when it's running, you'll see those also spinning.
All the fans.
All the fans spinning.
What about the inner classrooms? Will it show the exhaust on those on the roof?
You mean it shows the exhaust inside the classroom if it's running or not, or?
All the inner classrooms, all their outside air comes up to that on one end and the other end.
Those are the 2 brand new supply fans.
Oh,
that we
yeah.
just installed over
And will it show it on there?
Yeah, after maybe Monday, after the control will be done and will be
Okay.
tested, then it will be added here on the
Okay,
graphic.
no
Yeah.
problem.
Mhm, Yep.
So there'll be 2 more graphics.
Yeah, it will be added once it's ready. It will be added. Yep, for sure. And I will call you about it. There's not a lot of things going on. It's just like a speed-driven supply fans with a static pressure sensor.
And I'll need to be able to close in too.
Yeah, for sure. Like you'll be able to do that. Yeah, basically you will need to shut them down
Yes.
completely. If
If
you have
it gets real cold,
if you have a cold day, yeah, that's fine.
kill them.
You can kill them, or you just
Or
rely, or
sometime-
just
sometime mode, I can kill them.
or you can rely on your, you know, economizer. It'll be shut down on each individual equipment. I'll start from the room summary here. Okay, as you know, this school have 1, 2, 3, maybe 4 different type of equipments for the HVAC. You have a UVs, you have a fan coil, you have AHUs, and you have ACUs. Okay. This summary shows you room summary for the UVs only, altogether, but there's another page. So when you want to navigate, will be those numbers, 2, 3, 4. You're now at page 1. If I go to page 2, it will show you on page 2, and then you can look at the rest of the UVs. And I had a purpose to isolate the UVs from the FCUs, not to put them on the same summary. They have a slightly different feature, so you don't want them to be on the same page. Okay. Mm-hmm. Fan goals, that's right. Pretty much, the summary page hold the same information: set point, temperature, humidity, CO2, economizer, mixed temperature, discharge temperature. So this is an example of the UVs that you have on the school. Of course, the actual UV is not that big of a size. It's more concealed, it has everything cramped together, but here I'm trying to show more of the schematic, how it look like, okay? You have a damper for the outside and the return with one actuator, and you have a facing bypass damper. The feature of that facing bypass damper, if it's closed, it will shut the air flow through the coils, okay?
Will it show it on there as actually closed?
Yeah, it will show that is 0 on the coil and 100 passing the coil, okay? There's not 2 dampers, like also I said, 1 damper, but this is just a schematic view, so you can realize what's going on, right? When this one is shut, that will be fully open, and 50-50, so yeah, but it's just bypassing.
Okay.
And, you know, one of the feature of the facing bypass damper is meant to control temperature. It's like you can go with opening a chilled water valve for 100%, and then you control how much of air going through the coil to have a precision control of your discharge temperature, your room temperature, and so on. But the sequence that we had for this equipment wasn't involving the facing bypass damper to do that job. It was involving only modulating the valves to control the temperature. So there's one advantage right now of that for you guys, in case you have a valve stuck open and you're trying to stop that hot air or super cold air from going through. You can shut the facing bypass damper to 0 position, and then you'll have your air bypass through the coil, so you don't have that super hot or super cold air going through. You know, those are chilled water, hot water systems, so when there's a call for heat, the hot water valve will start to modulate from 0 to 100. We're also trying to maintain a discharge temperature. We don't exceed over a certain temperature. Chilled water valve also on the cooling mode, it will be modulating. And there's the dehumidification mode where both of them will work together. Chilled water valve will go 100% open, trying to absorb as much humidity or condense as much humidity as possible. And whenever there's a drop of a temperature in the zone, the hot water valve will modulate to maintain.
Will we be able to see that face bypass damper and outside air damper? Can you actually see it with your eyes to know if it's open or closed, or see the shaft?
In the equipment itself?
Yes.
Yeah, but it's very tight. Yeah. So that will be on Jeff on those UVs.
The reason we got these odd questions is that was the worst school in the whole school system. That stuff was junky. All of it was junky. And you couldn't get to the valves, it's hard to see the face bypass damper and the outside air damper.
So the valves of those are in the ceiling style ones are pretty accessible. So over the ceiling tile you can see the valves there, the actuators, they tie beside the equipment, and then there's the floor style equipment where you need to just open a panel and you will see the valves and so on. So those kind of features are accessible. Fan is accessible, but sometimes it's the dampers, the outside damper, probably a little bit of tight area for those. But I mean, there should be always a space to reach.
Can we, will we have control over like just say we thought something was wrong with the face bypass damper,
and we wanted to go there and test it. Can we make it? I guess, can we make it move?
From here?
Yeah.
Yeah, you can. So the facing bypass actuator is here, this one. You can override this one if you want to. And you have the ability to force it and for a timer or whatever, but once you force it, you'll be able to see change in temperature or at least, I mean, one of the feature or how the way to troubleshoot it from here. You can, for example, lower your set points or drive your set point up to 74, whatever.
And then you're gonna see your
See-
facing bypass.
And then you start to have some heat going through the coil, right?
Yeah.
Now force your facing bypass damper and see if your discharge temperature is actually changing after you force the damper. If it changed, then you know your facing is working. Is it stuck or not? That's the
I see 100% there. Is it 100%
open.
through the coil?
Yeah.
100% through the coil?
That's right. 100%. Because you see the damper is on the coil side. Okay?
Will that modulate, would show like 50%?
Yeah, this one will modulate.
Did you say in your sequence, you're not actually using the bypass feature? Or are you using the bypass feature to control the through tip?
No, we're not using the bypass feature to control the temperature. Because that's what we thought at the beginning. When we have a facing bypass, that's what we thought. That we thought we're going to use the facing bypass to control the temperature. And after we went through the sequence and the specs, and we made a contact with the designer, they said, well, we want the modulation to work on this.
So is there a reason for it to go into bypass now, or should it always?
As I said, there's no reason, but if you want to, if you have like a issue with a stuck actuator, stuck open,
Right.
giving you a hard time, to get there and stop that from happening, you can.
So when
That's wonderful.
so when that's satisfied, it's gonna go in bypass.
Yeah.
No, this is, as I said, it was controllable.
So you're telling me that it's gonna be controlled modulating hot water valve or cold?
Okay, so the main concept of facing bypass, if you want to do a facing bypass control, is to modulate that damper with the coil. So you go open your coils like 100%. Go chilled water valve, 100% open, hot water, 100% open, for example, and the only thing you control is your facing bypass, okay? That will control your discharge temperature, and then you will satisfy your space with that. But what you have for that job is not a facing bypass control by spec or by sequence of operation. So rather than using the facing bypass, we go in the traditional way, which is just modulating the valves. At that point, the facing bypass, the only function of it will be if you have a stuck open valve, maybe. Also, you can use it probably. It could be useful when you have a freeze situation, for example. Like you're trying to stop the airflow through the coils where it's like, frozen outside, and your outside damper is stuck open.
Is that in your sequence? If your outside air damper sticks open?
It's not, but we suggested that to the engineer if he don't want to do that, and he was kind of like the idea of it. So
Yeah, I think that's a good idea. If your mixed air goes below a certain amount,
yeah,
bypass your coils.
yeah, that's where it can be used also. So we gave him those two options, like here and there. So he went with that. At least we can make a, advantage of it. Now the freeze-stat here, that freeze-stat, if it sense any below freezing temperature going through the coil, it will turn red. It will shut down the fan. There will be no more airflow. And it's a hardwired feature. I mean, you cannot override that. You cannot reverse that.
Where's it at?
Is that
It's-
an automatic one?
It's automatic, yeah.
It's an auto reset.
It's an auto reset. It will reset itself. Whenever the temperature will go down, it will reset itself. Now, the way it's being wired, just to give you an indicator, it's being wired on the power line of the fan motor, okay? So, if you turned off the power on your UV, even if it's like temperature normal, you will see the alarm of freeze stat will popping up also. Why? Because we getting the information from through that freeze stat as a power indicator, okay? And since it's on the power line of the fan motor, if you turn off the power, you will have a freeze stat indicator too. Now, how to distinguish the difference? I mean, it's obvious if you see a mixed temperature of 32 degrees, that's obviously a freeze stat.
So if the freeze stat is correct, you're not gonna have a fan.
That's right.
Will it bring on the hot water valve 100%?
We don't have it in the 7 sequence, I don't think so. But
Yeah, it fell open.
no, but we can do that. I mean, we can do the tweak for this.
Is it, that's how man is, ain't
Yeah, it's still low.
it? No, I mean, if the freeze stat trips, you know.
You're right. You're right about that. You're
You
right
know,
about
the
that.
hot water up 100% to calm back the freezing.
Keep it from busting full.
Yeah.
So the reason we're asking all these questions about this is we had about 19 coils freeze busted.
Yeah.
So that means you need the chilled water and the hot water to be fail open, right?
Well, if that freeze stat trips, it should bring the hot water valve to 100%. What do you think?
I agree.
You have also, those are ECM motors, so you have a control over the speed of those fans. If you like to increase the fan speed, you want to lower it down, you can do it through there, but those are balanced, so there's no reason to change them at this point in time. Sometimes I see the balancers go really low on his set points to the point I lose my status, so I'm probably going to go over his set point by a little bit just to gain that status back, okay? Now you have, again, an outside minimum position, max position. We explained that before on the other job. Where you probably, what he meant here, he meant to put that in the minimum, but I don't know why he put it in the maximum. I'd rather to have another position for the maximum if it's possible, because right now we're running at 0 unless our PPM will go higher than 1200.
So if we're gonna change the temperature in there, we're gonna do it on the controlled space temperature.
Yep. Set points, control space, set points. And once you change it, it will affect the heating set point and the cooling set point. Exactly the same concept as the.
Like the Limo, Honeywell.
Yeah. You see that the difference is pretty obvious. Control space set point is 73. Your cooling is 75, and yeah. Here you have also the trend for your temperature set point, humidity. You can look at that. Same trend we showed before. We'll show you what is your temperature, set point, and humidity. The unit failed alarm, it will happen when you're losing a fan status. Of course, you'll see here, this one will turn to be reddish fan situation, and this one will say it's active. You probably want to reset and wait for a few minutes. The unit will recycle itself and start over. If you have a confirmative status, like you know your fan is running, okay, but you don't have status, then you probably have a little bit of bad CT at that point in time. You can contact us or just increase the speed to see if it's just a lag of amp. So.
Does the fan speed modulate on that, or is it,
No, it's fixed. It's a constant.
once it's balanced, it's,
Yeah,
It's a heat fan speed lower,
it's constant.
slower.
Yeah, we didn't have a heating set point for the fan speed. I mean, the balancer was there, and I don't think he have on his list like a certain CFM just for heating or a certain CFM just for cooling. So we have different set points to work with that. But The only thing we have is one set point. Any question about the UV? Okay. Let's go to the floor plan, and then we can jump to the fan coil unit from there also. I mean, it's also on the summary pages, but we can look at it through the floor plan. So again, you have the first floor, second floor, and you have section B here. Starting from the first floor.
Now, you told me that, just say like a Saturday, they're having a ball game in the gym, there is a chance that it could get too cold, and trip the alarm, because it's only one.
You talk about the chiller?
Yes.
Yeah. See that, I will get to that point. I will
Okay.
just, let's move on the fan coil unit, and then I will talk about the. So back to the floor plan, the way you can tell the difference between a fan coil unit and a UV, from the last section here, there's no economizer showing up on those fan coil units. There's an outside damper, yeah, on it, some of them, and some of them doesn't have an outside damper, especially the corridor ones. But you can tell the difference. The UV have economizer value. The fan coils does not.
That's pretty awesome. The fan coil doesn't have what now?
It has an outside damper, but it's not economizing. It's either on or off. That's the difference. Pretty much, it's very straightforward equipment. It's had fan, also ECM, has a different speed, have a chilled water valve, hot water valve.
Are those DC, water valves?
Yeah, those are 2 to 10, the analog one. But the one on the UVs are not. They're different because, I mean, you probably,
2 to 10 and 24, that's the same.
yeah,
You'll
24.
have your 24 volts powered up, and then you'll have your signal, which is your white.
It's similar to what it was.
You got your whole voltage and you
On the UVs, you'll have 24 volts on either side, depending on its opening or closing. You either get 24 volts from one side or 24 volts from the other side. That's how it works. That's on the UVs. Okay. Pretty much same information. The occupancy, the fan speed set point, space temp.
The hot water valve is closed. Then it's got 24 volts on.
Both those valves are modulated, correct?
Yeah.
Then it would be 10 volts or 0 volts, or 2 volts, whatever.
No, he's talking.
That's on the fan coil units.
Yeah, he's talking about the unit
I'm not-
ventilator.
Okay, on the unit ventilator, it's a pulse. Okay? Pulse means when it's trying to open, it will pulse 24 volts to open. And you have like 3 terminals on them. When one terminal will show you pulsing 24 volts to the open side. And then it will pulse 24 volts if it's trying to close. It's not going to be constantly
Just
24.
like man metal, on the gymnasium units, where, when we test them, you kind of knock 24 volts on it and take it off. Same way. Okay.
Let's get to the part of the chilled water loop. Want to go over the chiller?
Yes.
Okay. The water balance not completed on Logan Middle School. Now that chiller has a very important spec that it should require a minimum flow in order to operate. If you don't maintain that minimum flow, you might cause a problem. It goes to loss of water flow. That will trip the chiller down. It will shut it down, and it has to reset. You have to reset the alarm and start it over. That's what happened multi times. Hopefully, when the balancing done, we can specify how much flow that we have on the minimum flow on the system, how much the minimum speed for the VFD of that pump, so we can always maintain it. Now, it's around 250 gallon.
Per minute or something.
GP.
Yeah, per minute.
Do you have a way to directly measure the flow, or you just base it off the pressure and the
So
speed?
if the balancer will be able to determine what is the minimum, what is the minimum speed for the chilled water pumps, with the same time, if he can balance a bypass valve for that, that minimum with the bypass can maintain the same differential pressure and assure that the minimum flow is going through the chiller without having this problem. Because the other way to fix that is going through adding basically a water flow meter and controlling the flow meter through it's a different process, and it need some time and of course budget to make it happen. So
Where's the flow proven switch at?
It's in the chiller.
It's in the chiller, so it's not like the last.
No, it's inside, it's electronic.
Okay.
now those pumps, they run in a lead lag. Right now we are the lead at number 2. You can see here the occupancy is active, supply temp is 71, return temp is 71, or water pressure set point is 10, which is I have that like by not from the balancer. I just put a rough number to get at least over a minimum speed of the fan. Like over the chilled water pump to go over 70%, 80%, since you have a 2-floor building. The outside temp is 60, and outside temp set point is 55. Now, what that means, the chiller shall not run till the outside temperature past 55, because that's going to be also the same temperature, or before that, below that temperature, maybe 54, 53, your economizer mode will be stopped on all the equipment. They're not going to look for economizing, they're going to demand chilled water.
Does that thing got a gauge on your water flow?
A gauge over what?
For the water flow. You said it won't run if the water flow is not.
Yeah, I don't have a flow meter, if that's what you're asking.
He said there was a digital one.
It's on the equipment, but I don't have it here. You will see now on the boiler, we have a flow meter that's on the system, which is I would prefer to have it here rather than the boiler, to be honest with you, but that's how it comes. Now, when the chiller is running and is trying to maintain the supply temperature, you will see the compressor lighting up green. That will tell it's a real status coming from the chiller, from the power side of the compressor. When the compressor is ramping up, you will see a green status coming from the compressor, and you see the condenser fan.
So it has what, 4 compressors?
No, not necessarily. I don't. It's just like 2 maybe.
I didn't start the chiller up.
Yeah, I don't remember. And of course, no 3 fans. It has much more than 3 fans. This is just a schematic look.
There's 2.
2, yeah, 2. But the fans is like, I don't know.
There's a ton.
Yeah, it's like maybe 10 on each side or something like that. 10 on each side, like 2 rows of 10s maybe.
I think
Yeah,
so.
yeah.
And you can tell from the home screen, or the floor plan,
Roof plan.
roof plan, it's fans is working.
Well, that's just a animated. It's not a real status. That's related to the status of the compressor.
That just
because-
indicates
So
that
it-
it should be running.
Well, yeah. I have a status of the compressor itself. So if the compressor is running, the fan's supposed to run too. They're working together most of the time.
So the fan has to be running no matter what.
Most of the time. Yep. Yeah. Now apparently the chiller was running for a little bit. After an hour of running maybe or so, there's a delay on the alarm. That alarm will pop up, will say it's water temperature alarm, because right now we're calling for it and the supply temperature is not maintained. We want 55 degree, maybe 45 degree, and it's not there. So after a little bit, this thing will go red and you'll know, and it will never go until you reset it, okay? It will stay there. Now the pump, you have 2 pumps, so whenever you have a pump failure, like you're losing a status on the pump, it will automatically switch to the other one. The one like if it was like lead number 2 and lead number 2 is failed, it will switch to be lead number 1, and then we'll send an alarm on the screen saying, hey, this one is failed. So you probably want to troubleshoot it, see if there's a power issue, a VFD issue, whatever can be involved in the pump to make it operating. And all,
Can you reset the microprotection here? The alarms?
not yet. That's what you have on the chiller so far. Any questions?
Do you set the supply set point, or does the chiller
It's
do
local.
it based on outside air? or-
It's local, yeah, based on outside air. It's a local set point, like this. It has, the chiller have its own outside temperature, and it resets itself from that.
Can you pull out its set point and put it on your graphic?
Yeah,
Or you can verify
yeah, we
if
can.
it's at
You-
set point?
Yeah, we can do that.
Did you say it was set at 55 a while ago?
It's like about 50, 45, something like that. Depends on the outside temperature. But again, all those issues will be probably finalized, resolved after the water balancing completed, and hopefully we don't have this issue anymore, because it happens multi-times.
So below 55, your chiller's off.
Yeah.
You're just economizing
Yeah.
for all the UVs.
That's right. You have problem with that?
And it was amazing. When does the economizer quit bringing in outside air? Like,
Around,
what's its temperature? 40?
no,
35?
53, 52, something like that.
When it stops?
Stop,
bringing-
yeah, stop economizing. So that's, you have like 2 degrees, and then you will start using the chiller.
No, like your low outside temperature to
When it's
stop.
really cold outside.
Yeah,
Oh,
you're
you're
not
talking
bringing in-
about,
You're not
well,
bringing in 0.
oh, bring it in 0. That's when your mixed temperature is getting below 40. Below 40.
40?
Yeah, below 40. Like if you're 38, 30, 37, at that point you'll stop.
You're saying when mixed air goes below 40,
Yeah,
you'll start cutting back outside air.
that's right.
Okay. So it doesn't just go off of what's outside. It'll actually, it can bring in 0, but as soon as it starts
Well, from
dropping.
about 50 to 37 or so, it's going to, if you let going lower than that,
You can go through it.
freeze.
You can
Yeah,
go
but
through
that's, he's saying the mixed air, you're still gonna bring 0 in, right? But as long as your mix don't drop.
Yeah, because that's what your indicator about what's going on with the unit itself.
Okay.
Like if you have the mixed air 45 degree, okay, and it's 25 degree outside, why would I care? Because that not going to affect your equipment. That's the mixed air is the indicator of what directly affecting your equipment, not just the outside air itself. You have damper, you have percentage. So if your percentage, you have an air leak with your damper is not maintaining the mixed temperature as it should, go to 0. That's fine. That's what the control for. But if it's still maintained as it should, then we should be good. There's no reason to push that back.
Is this like the Chapmanville building, even if the CO2 is gonna override it no matter what?
Yeah, if your mixed temperature is getting really low on the minimum position of that damper, you rather have a space temperature control or no control at all. So that will shut down your fan. You go to freeze stat. Now this space, you cannot control, of course, the CO2 because there's no outside air anymore. And you cannot control the temperature because the fan is not running anymore. And now that space will be like, that's it, need to be cleared, right? So the hot water. So you have 2 boilers that are running in lead and lag. Your set point for the boiler will be automatically resetted by the outside temperature. There's a ratio to that. Whenever you have a lower temperature on the outside, your set point will be higher. Whenever it's warm up, it will go lower. So there's a range. The range goes anywhere between 120 degrees up to 180. Okay. Same thing for the pumps. You have 2 pumps, and lead and lag. Every one of those showing a run time, how much they've been running. And if there's any alarm going on the boiler, it will show here. of course, if there's an alarm, the boiler will also switch automatically to the second one. If it's like on lead 2, it will go to 1. If it's like 1, it will go to 2. The alarm will monitor the supply temperature. If the boiler running for a specific amount of time, let's say 40 minutes, okay, 45 minutes, and it is off the set point by 20 degrees or something, at that point, it will go to alarm mode and it will switch to the other one. And of course, you will see out on the screen, you can reset that. Now this pump here is an alarm. You can see it's run 30 hours versus this one, 720 hours. So I can reset that, and after maybe a few days, the lead pump will be number 1 again, and you will see it running. But this one, it has an issue for the last few weeks where it's losing status in the midway. Like I'm at like 80% of the speed, I have a status, and then for a sudden, the status will just disappear. There's no pump status. And then the program will automatically catch that, it will shut it down, and it will turn to the other one. And probably also we're going to check that tomorrow. We want to check the CT on that one to make sure it's being set up right, because this is a VFD type CT. It might need to be relearned after a while. Okay. You have a water flow meter on here, give you how much of a flow is going on. Like right now, it's 200 gallon per minute. You have also a water pressure differential that show you how much the differential pressure on it. Set point wise is being set also by me, not by the balancer yet. If we get that done, we will have a different set point for sure. And we want to keep that set point, fixed there forever without being changed. Okay. Here you have, if you see the boiler info on this side, you have the information of the lead boiler, and here the combustion dampers. Those combustion dampers, they work to serve the boilers and the domestic hot water heaters that you have there. Normally, if you have one boiler running and the domestic hot water is not running at all, you'll have one damper running. If you have two boilers or a boiler and the domestic hot water, you'll have both dampers running at the same time. I mean, the domestic hot water may be going to run most of the time, even more than boiler, right? You want to keep that maintained. So most cases, you will see one damper shutting down and the other one will be on. Okay?
Dampers on the graphic.
That's the status of them. They don't have like a modulating value. It's like an end switch telling you if they are like hit the end of it or not. So the status is open on both. That's the purpose. I mean, we can put it on the damper on it.
Where's it at? I didn't see it.
It's here.
Okay, gotcha.
As I said, I can't put them as a graphical shape of it, but there's no midpoint on it. It's like also 0 or 100. So it's just like the end switch what tells you if it's open or not on those. Now, this one here is an optional thing. I just added that. If you don't like it, we can take it off. The purpose behind that, along the way, if you got some issues with the boiler and you want to run them both at the same time, the run both override will push them both together to run for a 24 hours period, and then it will reset itself. It will back to run one boiler at a time. So it's an option. You don't want it, I can take it off. It's not part of the specs of this or sequence, but it's just something I like to have. The RTU summary. So that where you have all the ACUs and the AHUs on the same page. That tells you each one of those and what it does. Now those units, the difference between them and every other equipment you have, those are a Microtech controllers. BagNet, Microtech, factory controllers, okay? There's not a lot of override you can do on those versus the other equipments, okay? You can change set points, maybe occupancy, pretty much that way you can change on those. Other than that, it's all self-controlled. Now, between the ACUs and the AHUs, there's two major differences. The ACUs is a DX cooling gas heat. The AHUs have chilled water, hot water coils. The ACUs have a wall stats adjustable. The AHUs does not have a wall stat adjustable, just a space temp, so the set point has to be changed from here. Okay, that's the main difference. So if I go here to ACU1,
So ACU one is basically, it is the principal's office area. That's what it serves at.
yeah, the administration area. We can go to the floor plan bag, and I will show you on the floor plans.
Where's the thermostat to that one at?
This ACU1 is covering that area. As you see here, ACU1 is covering this area, which is the administration area. On that one, you have also space temp, control set point, and cooling and heating set point. This is a DX coil temperature. This is the temperature on the cooling coil, okay? That's a good indicator. For example, if you have a hot gas reheat situation where you're trying to dehumidify, you cannot tell if it's really working or not just by looking at the discharge temperature, right? Because already your discharge temperature may be a room neutral, right? So when you have a dehumidification and you're looking at it, you may be your hot gas reheat 25%, 30%. Your DX coil may be 100%. If it's 100%, the DX coil temperature gotta be something 50 and below, 52, 49, something like that. That will make sense because it's working. It is dehumidifying. It's doing its job. But if you're looking at it as like 100% and hot gas reheat 50 or whatever, and the leaving coil, the DX coil temperature, is still like 75 or something, you got an issue at that point in time. So this is a troubleshooting temperature more than anything else.
What should you look at the DX cool temp for troubleshooting purposes?
When you're in dehumidification mode, most of the time. Because if you're in cooling mode, you can tell by the discharge temperature only that it's working. But if you're dehumidifying, and you have a hot gas reheat, your discharge temperature may be already at 70 or 69. In order to tell if your equipment is doing its job, is looking at the DX coil temperature and see if it's like 49, 48, 50. That means it's working efficiently. Now, every once in a while, there will be an alarm maybe popping up here, okay? Numbers can vary. You can have number 100, 200. It's just an alarm value. But what does that mean? That's what the guide will tell you. If you click on the guide, that will show you every number. 0, no active alarms. And the list goes on. So any number coming up on that screen, you go to this guide, it will be translated. This is your index of the alarm, basically. Does it make sense?
Does that match the factory?
Yeah, that's the factory alarm.
That one?
Yeah, that's the factory index.
Can you click back on that?
Oh, okay.
What is this?
You see that one?
What's that?
What's this circuit,
Yeah, I seen it.
1 through 8?
So the index can cover a bunch of equipments, not only this equipment. Okay? So apparently the equipment will show only the related alarm to itself, okay? So if there's like alarm going with the circuit 1, if you have this alarm with emergency, with most of the time, those equipments, they may fail either on emergency stop or they may fail on a low discharge temperature. Sometimes you'll have a low discharge.
This guide covers.
Bunch of equipments.
Okay.
Yeah.
That's what I didn't know if there was any. Is there anything up there with more than 2 circuits besides the chiller?
I don't think so. No.
Okay.
Now, this is all global schedule too, this one, right?
You have schedules here. Those schedules kind of like, you have a chiller schedule, you have a boiler schedule, you have the common area, the library, you have the first floor, which is cover every UV and every fan coil, and you have the second floor, which cover also every UV, every fan coil.
Okay.
You have the computer lab on the second floor, which is 3 ACUs in that area. You have the gym schedule, which is the gym units. You have the music zone where you have, you know, the band or whatever, and then the kitchen and the admin area, which is ACU 1. And this is the AHU. Right now, also calling for cooling. Chilled water valve is also fully open, but again, chiller is tripped, so there's no chilled water going on through the loop, and that probably.
That's your commons area.
Yep.
Right there.
Mm-hmm. You have a hot water coil also on that one. It will work from the factory in the dehumidification mode. Both of the coils will work together to maintain humidity set point. Which right now is 50. It's pretty low. I mean, you can put it at 55. It'll be, you know, more efficient. Every one of those also provided with a CO2 sensor, and it's supposed to maintain a CO2 levels on the ventilation. That's being determined by the balancer because those being balanced. Okay. Now, if you notice here, you have a fan set point, that's a controllable point. Either it's like a factory control, but you have the ability to change the fan speed on those equipment, from the ACUs down to AHUs, all of them.
So you recommend leaving it right where it's at?
Because it's been balanced on that.
Okay, that's fine.
Now, you see that use T-stat set points?
Yep.
On the AHUs, I will never, ever recommend to switch that to yes. Always a no, because there's no such thing a local stats to be adjusted on the AHUs. Once you change that, you'll probably have some issues with your temperature control.
I got you.
On the ACUs, if you have an area on the ACUs that you like to have somebody having a local control on them, like say here, like ACU 2, for example, I also put it to no on those units. But those, the ACUs only, you can give them a local control. You can turn that to yes and let it roll by the local user, if you'd like to. If you don't, just keep it as it is. Because most of those equipments are covering a area where it's like kind of like commons area or like general area where you have a lot of students going.
Yeah, and then backside there, you got a real big room.
Yeah.
And then you got that where the garage door is at,
Mm-hmm.
which will be on one of those.
If you click on just them units that you just said,
Mm-hmm.
does it show on the graphics the area they serve?
There it is.
Okay.
Yeah, like right here.
That's what I was wondering.
Mm-hmm.
So like room 117A and 117B, that's the game room.
I got you.
Those two right there. 122 is the room with the
Garage
with the
door.
garage door. That's the what, the hydroponics or something.
Let's look at this. Since the alarm is here triggered, the alarm view here on Logan will show you a bunch of alarms here. First one is the chiller supply temperature over the normal, okay? You can see the message, you know, out and clear. If you don't want to go through every graphical page and look what's going on, you just click on the alarm view and it shows you what you have. Of course, there's another way of receiving the alarms by implementing an email notification and overwhelming you guys with all kind of notifications. Up to you also. You can have that option just for the critical alarms, but I know a lot of people doesn't like it. You have also here the hot water pump 1 alarm, okay, that shows us an alarm, and you have a CO2 out of range alarm. Now that's happening in certain rooms. I need to.
And that's because those supply fans and all that.
Yeah. So you're looking at this. You click on the CO2 alarm. It will show you some details on the right. CO2 out of range alarm. This is the text message of the alarm. Okay. And now it tells you what is the source. Where's the alarm coming from? It's Logan middle. This is the name of controller or the name of network of the controllers that's serving, and then it says UV104. This is your room that having this issue. You go here, it will tell you UV106. Go here to 105 and so on. So it will show you what is the source. Every controller you have is named with the actual room number. So when it shows you the alarm, you'll know right away which room has the alarm. Okay. Of course, you can acknowledge the alarm. You can hide the alarm. Assign it to me. You can assign it to yourself, myself. So that when you assign it to yourself, that means you're going to handle it. You see the HV, that's HVAC. Now, if somebody logged in after me, he will see that HV here. That means HVAC user.
That was one of us.
Yeah, one of you. Well, HVAC is basically me. But if you're logged in with your credentials, it will show your access.
Okay.
Okay.
That's good.
So somebody assigned that to himself, you'll know, okay, he's going to handle it. That's good. Or I can acknowledge it, it will disappear. Not there anymore. Now I can modify that so to keep the acknowledged alarm always in the log. Okay? Even if it's been acknowledged, you can still see it. Okay?
Say you acknowledge one, it disappears, you still have an alarm on it, it'll show that good.
We'll show. What we can do, we can keep the acknowledged alarms in the same list. Right now, I didn't want to make it, overwhelming because maybe there's been a lot of acknowledged alarm in the past. So we can add the acknowledged alarms, and you keep it there as a reference. You go back in the log, see, okay, this one acknowledged that day, that date, with the initial who did it. It will tell you who acknowledged the alarm. All right. I hope you just keep navigate the system, ask questions. I always say, the first look, you'll be the first troubleshooter. If you have any issue, any problem, something, could be a bug in the system, something not being implemented correctly, a literal mistake, give me a feedback and I'll fix it for you, okay?